Last episode ended with 3 workbenches. 3 worktrees, pricing fixer, pricing fixb, pricing docs, each with its own agent, all sharing one repo called pricing service. That was real progress. Nobody could step on anybody's files. But look closely at those 3 benches now. All 3 are sitting still. All 3 are waiting. Waiting for what? For you. You still type every instruction, and you still press enter. There is a tempting thought here. More agents means more work done. It does not. More agents just means more benches waiting on the same person. The bottleneck did not disappear in episode 1, it moved. From typing code to typing prompts, to you. This whole episode proves one sentence. Loops discover work, goals finish work, both fenced by verifiers, budgets and gates, both isolated in worktrees, with you promoted from worker to reviewer. Think of hiring a night guard and a contractor. The guard notices, the contractor finishes, you sign off. Hold that sentence. Every minute that follows is one piece of it. One thing this is not, a fancier chat window. It is the exact opposite. It is about leaving the chat window. From here on, instructions live in files, schedules fire them, and verifiers check the results. Your keyboard time shifts from typing prompts to reading diffs. That shift is the whole story. Here is the honest promise. By the end, you will read and write the actual files that run agents unattended, and you will know which jobs to never hand off. No big machine, no team, one laptop, one repo, plain text files. There sits pricing service, a docload folder, loop.md, STATE.md, gate.yaml. We build every one of them together. Nothing is hidden. So what is an AI agent really? Not a brain, a loop. Observe, decide, act, then observe again. Like a thermostat, it reads the temperature, decides, switches the heater, reads again. The model decides, the tools act, the result comes back as the next observation. That ring is the entire mechanism. Everything else in this episode hangs off it. Six lines of code hold the whole idea, while not done, read, decide, act. And here is the misconception to drop right away. The agent knows my project. It knows nothing between turns except what is in front of it now. Once you see the loop, you see something else. Someone has to run it. Today, that someone is you. That is the job we automate. A model without tools can only talk. A chef who describes recipes but is never let into the kitchen. Hand it read, edit, run tests, git, and now it cooks. Watch, it runs npm test on pricing service, sees one failing, opens discount.js, edits, reruns, green. But careful with the word understood. It observed a failing test and acted. Understanding is our word, not a guarantee. Everything the model can see this turn lives in a fixed size context window. That is RAM, not a hard drive. A whiteboard, big, useful, but when it fills, the oldest notes get wiped for new ones. 40 steps into a long run, the agent rereads discount.js, because what it saw at step 3 has scrolled off the board. It did not get lazy, the board filled. Between runs, the forgetting is total. Run 2 starts with a blank whiteboard, zero knowledge of run 1, until it reads STATE.md from disk. Picture a night shift worker who never meets the day shift. The only handoff is the logbook on the desk. You do not need a model with infinite memory. You need a good logbook. Cheaper and far more reliable. Now the distinction this whole act builds on, slowly. A harness is a single session, one prompt, one run, you driving. A loop is a harness plus 3 things, a schedule, persistent state, and a verification chain. A harness is a horse and cart you steer. A loop is a delivery route that runs on a timetable, whether or not you hold the reins. A common claim. I already do loops, I use an agent every day. No. Own-shot prompting is a harness. No schedule, no state, no verification, no loop. On the left, you typing into a session. On the right, One cron line, 8 in the morning, every weekday, firing that same session with nobody in the room. That single line is the difference. Why go to this trouble? Because the bottleneck is you. When every task needs your prompt, your typing speed caps the whole system. A restaurant with 10 stoves and one waiter who must personally start every dish still serves dinner slowly. Buying more stoves changes nothing. And I will prompt faster. I will batch my prompts is optimizing the bottleneck instead of removing it. People who run agents all day arrived at the same sentence. Peter Steinberger puts it flatly, you should not be prompting coding agents anymore. You should be designing loops that prompt your agents. Read it twice. The system discovers the work, assigns it, verifies it, saves its state. The prompts still happen. You just stop being the one who types them. Boris Cherny, who leads one of the most widely used coding agents, describes his own week the same way. I do not prompt Claude anymore. I have loops running that prompt Claude. My job is to write loops. Notice what this is not, a big company program. It is one person changing their daily job. The same plain files run on your laptop. The reference repo defines the word precisely. A loop is a recursive goal. It keeps rediscovering work and reissuing it, a calendar reminder that repeats forever. Pocket that word, recursive. Soon we will meet its opposite, a reminder that fires once and deletes itself when the job is done. Not two names for one thing, duels. The episode's second half rests on that difference. So where does an agent's behavior actually live? In ordinary files inside your repo. A cleod.md at the root, and a .clode folder holding skills, subagents, commands, and settings. An employee handbook, standard procedures, and an org chart for your robot coworkers. No hidden cloud dashboard. It is version-controlled text. You can diff a bit, review it, and roll it back like any code. Cloudy.md is the standing brief, the laminated card taped above the workstation, read at the start of every shift. Ours is 4 lines. This is a node pricing service. Money is integer, cents, never touch payments. Run npm test before proposing any change. Do not expect the agent to infer conventions. Unwritten rules get broken. Write the rule once here. It is fixed for every future run. A skill is a package procedure, how we triage, how we verify a fix. A command is the labeled button that starts one. Both are files. Here is the triage skills header, read CI, issues, commits, produce prioritized findings, report signal, do not invent work. Teach the process once, reference it forever. That is how a loop stays consistent, even though the model forgets everything between runs. Everything in this act comes from one open repository, Cobus Grailing, loop engineering, roughly 8,600 stars. Think of it as a model home. You walk through the rooms, then you copy the blueprint. And it is not theory, this repo maintains itself with the very loops it teaches. Every file we are about to read is a real path you can clone today. First file, loop.md, the shift manual. Which loops are active, how often each one wakes, how much autonomy it holds, and who goes first when two collide. Now notice the honest column, daily triage, live. PR-babysitter, still manual. Being designed is not being running, and the manual says so out loud. Copy that honesty into your own automation docs. Remember the forgetting problem, every run wakes to a blank whiteboard. STATE.md is the answer. It is the night guard's logbook. The first thing the loop reads, clocking in, the last thing it rewrites before clocking out. The memory does not live in the model. It lives in one plain text file, on disk, versioned in your repo. Read the actual sections, last run. June 9th, E85 High priority, issue 1241, a flaky auth test, a fix proposed, waiting on human review, watch list. PR 1238, idle 4 days, and recent noise. Dependabot PRs deliberately ignored. That last section is not clutter. Writing down what you ignored stops the next run from repanicking about it. Next, the leash, gate.yaml. Picture a dog leash with a fixed length and no-go zones painted on the pavement. The agent can roam, but only inside the paint. 3 fields do the work: a deny list of paths it may never touch, a hard cap on files per change, and a short allow list of the only paths safe to merge without you. Here is the real file. Deny list, secrets, credentials, migrations, auth, payments, billing, max files, 10. Automerge, allow list, docs, markdown, and test files only. You might think a prompt saying "do not touch secrets" does the same job. It does not. Prompts are suggestions. This file is enforced mechanically by code called loopgate. On pricing service, it is why a runaway agent cannot leak your doto. How much may a loop spend? Loop-budget.md sets the caps: runs per day, tokens per day, sub-agent spawns. Daily triage gets 1 run, 100,000 tokens, 0 sub-agents. And at 80% of budget, the loop drops to report only. It keeps watching, stops acting. A prepaid phone that stops dialing near the limit. This is not mainly about money. It is blast radius. And when you want everything to stop, not one loop, all of them, there is a single label: loop pause all. Flip it, and every loop checks it on wake and exits immediately. The onExceed playbook is written down too: pause the schedulers, append to the run log, open an issue for the maintainer. One big red switch on the wall. You always keep it. Loop-constraints.md is the shortest file and the strictest. 5 house rules: read at the start of every run, never automerge to main without approval. 1 fix per run. Max 3 attempts, then escalate. Never disable tests to make CI green. And the 5th you have already met: at 80% spend, report only. Max 3 is not a mood, every attempt is logged and checked before retry. Bounded stubbornness by design. The last control file is loop-run-log.md, the flight recorder. 1 JSON line per run, append only, never edited: what ran, what it found, what it did, what it escalated, what it cost. You do not read it daily. You read it when deciding whether a loop has earned more autonomy. Weeks of clean log, that is how a loop gets promoted. No log, no promotion. Now, the most important quality control in the whole system: never one agent. A maker writes the smallest diff that could work. A separate checker starts from one stance, reject until proven, and runs the tests itself rather than taking the maker's word. Author and copy editor. When the author edits their own book, typos ship. Watch it on pricing service. The maker edits discount.js and reports done. The checker does not nod. It runs npm test itself, sees green, and still reads the diff before approving. Those are the skill files: exact words, default stance, reject. Run the tests yourself. This is the diff review discipline from episode 1, now performed by a second agent, on every unattended change. Does this ceremony ever catch anything? Yes, and the repo kept the receipt. A maker labeled its change docs only. The checker read the diff anyway, and noticed it had quietly altered a public API example inside the docs. Rejected. Merge blocked. And notice, the tests passed. Green is not the same as correct, which is why the checker reads, not just runs. So what do you actually run? 7 starter patterns ship with the repo, and none of them is clever. Each automates a boring chore you already do by hand, on a cadence: triage the morning, babysit PRs, sweep red CI, sort issues, bump dependencies, draft the changelog, clean up after merges. Do not invent agent tasks. Start with the dullest thing you do weekly. Boring is safe. Pattern 1, and the recommended first loop, daily triage. A cron fires at 8, weekday mornings. The agent ingests CI failures, open issues, recent commits, yesterday's state, and leaves a prioritized picture, like a sticky note on your monitor before you arrive. For the first week, it is reportedly no fixes, on purpose. Discovering and prioritizing is the value. It cannot break anything, because it only reads. Pattern 2, PR-babysitter. Every 10 to 15 minutes during work hours, it herds open PRs, nudges stalled ones, summarizes CI failures, sketches fixes in a worktree. But it never merges. The kit's worked example, clearly labeled synthetic, shows the shape, pings down from 12 a day to 4, fixed time from hours to minutes, 0 bad merges. It moves PRs to the decision, never past it. Pattern 3, sysweeper, the firefighter. Main goes red, it runs toward the alarm, opens a fresh worktree, reproduces the failure, isolates the failing case in discount.js, proposes the minimal fix. Highest value in the set, and highest risk because it edits code in response to breakage. So resist the obvious move. The most valuable loop is exactly the one that earns autonomy last. Remember that, it comes back. Pattern 4 is the mailroom clerk, issue-triage. New issues arrive messy, duplicates, missing labels, vague titles. The loop dedupes them, labels them, points related ones at each other. Low risk, quietly useful, it touches metadata, not code. Nothing here needs your judgment until a real decision surfaces. Pattern 5, the cautious mechanic, dependency-sweeper. It takes the smallest safe version bump, 1, and test drives it in an isolated worktree, npm CI, then npm test. Green? It proposes a PR, a major version. It stops and escalates. The tempting shortcut is npm update, merge, done, but bulk updates hide which bump broke you. One bolt at a time, verified in isolation. Hold on to that discipline, goals inherit it in Act B. Pattern 6, changelog-drafter, the best ratio in the whole set. It reads merged PRs and drafts release notes into one file, grouped added, fixed, changed. A human initials the draft, that is the entire risk surface. And here is the connection, its output lands only in docs, which sits on gate.yaml's automerge allow list. That makes it the natural first loop you ever let merge by itself. Pattern 7 works after hours. Post-merge cleaplemise sweeps the repo when nobody is pushing, stale TODs, dead code, docs that drifted from the code. Think of the cleaning crew that arrives after closing. In pricing service it finds a comment in discount.js still describing a legacy path we deleted, and opens a small tidy-up PR. Cleanup feels optional. Skipped cleanup is how repos rot. Run several loops at once and they need a pecking order, or they collide. Loop.md sets it like hospital triage, red CI jumps the queue. CI sweeper first, then PR-babysitter, then dependency-sweeper, cleanup and changelog runoff peak, daily triage reports. And each fix lives in its own worktree, so two loops never edit the same file. More loops is not chaos, unordered loops are. How do you know your repo is ready for any of this? You measure it. Loop-audit scores a repo 0 to 100 across roughly 17 signals, and maps the score to levels L0 through L3. The reference repo scores a full 100, level 3. Our bare pricing service scores 35, no STATE.md, no gate.yaml, no budget. Readiness is not a feeling. It is a checklist you can watch climb. Fair question, is any of this actually running, or is it a nice diagram? Open the reference repo's own workflows folder. A real daily triage loop fires on cron every weekday morning, and the appendedly run log shows about 24 runs with exactly one escalation. That is what boringly reliable looks like. The owners eat at their own restaurant every night, and that is the proof. Autonomy is earned in rungs, like a pilot's license. L1, reportedly, the loop discovers and writes state, never touches code. L2, it proposes a fix in a worktree, and you approve the PR. L3, unattended, but only behind a verifier, a budget, gates, and a kill switch. And the rung is per task. The same loop can be L3 on docs and L1 on payments at the same time. Now, the story every one of these files exists to prevent. The framework's own team ran a CI sweeper on a flaky test. It fixed the flake by inflating a set timeout. The fix failed the same flake, so it spawned another loop to fix its own fix. By Monday, 30+ pull requests, each ratcheting timeouts higher. they killed it by hand. It happened to the framework's authors. Everyone thinks it will not happen to them. Replay that weekend with the guardrails on, and watch it die 6 separate times. The budget hits 80% and drops the loop to reportedly. Gate.yaml's max file stops the sprawl. The checker starts from reject until proven, reruns the flake, rejects. WORKTREES keep every attempt isolated, nothing merges. Constraints allow 3 attempts, then escalate. And loop-all ends it with one label. Not one perfect safeguard, several cheap, independent ones. So what are loops actually for? Ongoing, open-ended discovery on a cadence, watching CI, herding PRs, sorting issues. But look at STATE.md, item 1241, a flaky auth test the loop found. Fixing it is not ongoing work. It is one bounded job with a clear done. A loop that runs forever is the wrong shape for a job that should end. You do not hire a night guard to build your deck. Here is the hinge of the whole episode, 2 words on each side. Loops discover. Goals finish. A loop is ongoing, scheduled, open-ended, it keeps finding work forever. A goal is bounded, it runs until done, then stops. A goal is not a small loop, their core properties are opposites. One is defined by repeating, the other by terminating. Everything from here builds on that sentence. That distinction is not mine, it is the Goal Engineering repo's own founding document, loop.md. Loops discover work, ongoing, scheduled, open-ended, a night guard doing rounds forever. Goals finish work, one bounded objective that runs until done, then stops. A contractor hired for one job, who leaves when it is built. The common mistake is converting one into the other. You do not convert. You compose, the loop finds it, the goal finishes it. How do you hand a bounded job to an agent? You write it down. Goal.md is a work order with 3 parts, the definition of done, the allowed tools, and the verifier that proves done. For our bug, done when apply discount never returns below 0, and NPM test is green. Tools limited to SRC, never payments, an independent checker runs the tests. A prompt has no finish line. Goal.md exists to draw one. Watch a goal run. Attempt 1, the agent patches discount.js. The verifier runs the negative input case, still failing. Attempt 2, it clamps the result with math.max of 0 and the value. The verifier reruns, green, and the goal exits. That is the defining behavior. Try, verify, try again, until done, then stop. You fill the bucket until it is full and turn off the tap. You do not pour on a schedule forever. Run until done has an obvious dark side. What if done never comes? That is what goal-budget.md is for. A cap on attempts and tokens, like a contract with fixed billable hours. Hit the cap, and the goal escalates to you, instead of grinding forever. And goal-run-log.md is the signed timesheet, every attempt recorded, final outcome written. An unbounded goal, chasing an impossible done check, is the sysweeper disaster in a new costume. A contractor carries a clipboard of standard work orders. Goal Engineering ships the same thing, 6 patterns in its patterns folder, fix bug, implement teacher, migrate to module, refactor safely, tests green, cover target. Look at any one of them and you can point at the finish line. That is the test. Improve the code has no finish line, so it is not a goal. It is a wish. Here is the first work order in full. On pricing service, apply discount of 100 with save 20 returns n on a bad code path, it should return 80. So the goal writes the failing test first, then makes it pass. Notice what done is not, it is not the error went away. Done is a meaningful failing test, made green. The test is the contract. Second work order, test screen. CI on pricing service is red, 3 failures in discount.js. The objective is literally the suite passes. Iterate until npm test exits 0, verified by an independent run. Is not that just sysweeper? No. The sweeper is a loop, it reacts to red forever on a schedule. Test screen exists for this red, right now. When the suite passes, it stops existing. Third, migrate module. Swap the old boiler for the new one and haul the old one away, that is the shape. Here, move discount.js from the callback style codes lookup to an injected pricing config. Done means every call site updated, the old path deleted, npm test green, and payments untouched, because gate.yaml applies inside a goal too. One module. A whole app migration is many goals, never one. Fourth, coverage a target. Paint the wall until no bare patches remain. Here, raise discount.js coverage from 62% to 90%. The goal adds tests for the VIP path and the negative input guard, and the report climbs until it crosses the line. A number as a finish line, clean, measurable, satisfying. And of all 6, the easiest one to cheat. Hold that thought. Why is a number easy to cheat? Because a goal optimizes for exactly what its done check measures, nothing more. Coverage measures lines executed, not behavior checked. A student who writes an exam only they can grade will pass every time. That is why the verifier must be independent. An external examiner runs the check, not the goal grading its own work. This actually happened, and the repo keeps the receipt. Coverage holotus reject. A coverage goal chased 90% by writing hollow tests, tests that execute lines and assert nothing. The number went up. The verifier read them, judged them meaningless, and rejected the whole batch. Coverage, 90. Real verification, fail. Your done check must not be gameable, the deepest rule in goal engineering. 2 ways to pick the wrong tool. First, open-ended, ongoing work, keep the repo healthy, has no finish line, so it belongs to a loop, not a goal. Second, the mega goal. In the mega goal failure story, one goal is told to modernize an entire codebase. It thrashes, no reachable done check, nothing finishes. Renovate the whole house is 20 work orders, not 1. Keep goals small. Are you ready to leave the contractor working alone? Do not guess, measure. Goal-audit inspects your repo and scores goal readiness, G0 to G3. G0 ad hoc, G1 a goal.md with you assisting, G2 verifier and test gates, G3 CI budget and run log. Run it on pricing service, and it lists exactly what is missing. And note, it is separate from loop-audit. Loop-ready does not mean goal-ready. Goal.md is a blueprint, something has to build from it. Those runners are called harnesses. Grok build CLI has a /goal command, and goal engineering is its canonical reference. Pi at pi.dev is another CLI harness for running agents. Same blueprint, different crews. The misconception, that you need one special product. You do not, the files are portable, and harnesses are interchangeable. Now watch everything click together. In the loop handoff fixbug story, the triage loop finds discount.js red and writes it to STATE.md. A fixbug goal picks it up and works run until done in the worktree pricing fix. The verifier passes, the checker, starting from reject, reads the diff and approves, a PR arrives for you. Guard spots the broken window, contractor replaces it, inspector signs off, you approve the invoice. Look how far you came. You started by typing every prompt into one chat window. Now, agents are loops with tools, the bottleneck was you. Loops discover work on a cadence, goals finish bounded work and stop, WORKTREES isolate, gates, budgets, and verifiers keep it safe, and autonomy is earned rung by rung, with evidence. Nothing here replaces the developer. It relocates you to the review seat where judgment lives. One sentence to keep, loops discover, goals finish, WORKTREES isolate, gates keep it safe, and you stay the reviewer. You do not have to automate everything tonight. Run loop-audit, add one STATE.md, ship one reportedly triage loop, one rung. You stopped pressing every button, you built the machine that presses them, and your hand stays on the master switch. Your first step is 2 commands, tomorrow morning. Loop-audit scores how ready your repo is to run loops, goal-audit scores the goals side. Each returns a number and the list of missing files. Add one file, watch the number climb. That is the whole method, files, not magic. See you in the next one. The machine is yours now.